Hello everyone, and welcome back to the AI Research Roundup. I'm your host Alex, and today we're diving into a really interesting paper on visual generation. It's called SimpleAR, Pushing the Frontier of Autoregressive Visual Generation Through Pretraining, SFT, and RL. The core idea here is exploring how a relatively simple autoregressive framework, without lots of complex changes, can actually generate high-quality images. They show that even with only 500 million parameters, their model can create detailed 1024 by 1024 images and performs competitively on text-to-image tasks. They also found that techniques like supervised fine-tuning and reinforcement learning really boost the image aesthetics and how well the images match the text prompts. So let's take a look at some examples. Figure 1 here shows off the kind of results SimpleAR can produce. These are text-to-image generations, all at that high 1024 by 1024 resolution we talked about. You can see a pretty wide range of subjects and styles, from detailed portraits like the clown or the woman with the pearl earring, to animals in whimsical situations, like the raccoon in a coat or the cat playing chess. The image quality looks quite high, demonstrating that ability to generate detailed and aesthetically pleasing outputs they mentioned. Okay. So we saw some nice examples, but how does SimpleAR actually stack up quantitatively? Well, Table 1 here shows results on the Generative and DPG benchmarks, comparing SimpleAR to other models. And their 0.5 billion parameter version performs really well, getting an overall 0.59 on Generative and almost 80 on DPG. That's actually better than some larger diffusion models shown here, and way ahead of another similar-sized autoregressive model. It really shows this simpler approach is holding its own. We mentioned earlier that they use different training stages, including supervised fine-tuning and reinforcement learning. Well, Figure 2 here shows the difference that final RL step makes. The top row is the model after just SFT, and the bottom row is after RL training using GRPO. You can see clear improvements. The RL model correctly spells stop on the sign, it generates the right number of apples, 4 instead of 5, and it understands the spatial relationship, placing the wine glass next to the hot dog instead of putting the hot dog in the glass. So this RL stage really boosts the model's ability to follow the prompt accurately. Now, generating images autoregressively, token by token, can be slow. So the researchers also looked into speeding up inference. Table 5 here shows some of those results. The baseline inference takes quite a while, almost 228 seconds per image. But by applying techniques like KV cache, which is common in large language models, they cut that down to about 150 seconds. And even better, using VLLM, which leverages things like page detention, brings the time down dramatically to just over 13.5 seconds per image. That's a huge speed up, showing these optimizations are really effective. Okay, so we saw they can make inference much faster. But going back to that reinforcement learning step, we saw qualitatively improved things in Figure 2. How much does it actually boost the numbers? And does the specific reward used matter? Well, Table 4 here looks exactly at that, showing the Generative performance. We can see results for both the 0.5 billion and a larger 1.5 billion parameter model. The rows without a reward listed show the score after just SFT, while the others show results after RL using either HPSV2 or Key2 or clip rewards. Clearly, RL helps, improving the overall score in both model sizes. And it looks like using the clip reward generally works better than HPSV2, getting that 0.59 overall score for the 0.5B model we saw earlier, and 0.63 for the larger 1.5B version. Okay, so we've seen that reinforcement learning, particularly with the clip reward, boosts performance significantly. But no model is perfect, right? Figure 6 here shows some examples where SimpleAR does struggle. These are failure cases. You can see things like, well, anatomically impossible poses, like that dancer, trouble generating readable text, and sometimes getting physics a bit wrong, like the floating cigarette. The paper suggests these issues might stem from limitations in the training data scale, or the model size itself, areas where future work could improve things. So, yeah, while there are areas for improvement like we saw, SimpleAR really demonstrates a compelling approach. Taking those core ideas from language models, pre-training, SFT, and especially reinforcement learning, and applying them directly to visual generation yields really strong results. It definitely pushes what's possible with autoregressive image synthesis, showing this paradigm is still very much competitive. Well, that wraps up our look at SimpleAR today. Thanks for joining me on the AI Research Roundup. I'm your host, Alex.